Welcome to another video from explainingcomputers.com. This time we're doing a group test of 5 RISC-V single board computers. Specifically, we're going to compare the performance of the Orange Pi RV2, the Banana Pi BPI-F3, the Sipeed Lichee Pi 3A, the Milk-V Jupiter and the VisionFive 2. All of these have been released within about the past 2.5 years and allow enthusiasts and others to experiment with and develop for the RISC-V instruction set architecture. The prices here are the best I could find in May 2025 for the variant of the board that I own and which we'll therefore be testing. But note that all the boards are available with different RAM and onboard eMMC options, as I've covered in my individual reviews. As we can see, the Banana Pi BPI-F3 and Lichee Pi 3A both have a SpaceMIT K1 system on a chip with 8 1.6 GHz x60 cores. The 16GB version of the Milk-V Jupiter also uses essentially the same chip, a SpaceMIT M1, which is a version of the K1 with a heat spreader, so allowing it to be clocked slightly faster. And do note that the 4 and 8GB versions of the Milk-V Jupiter are K1 and not M1 based. Moving on, the cores in the KYX1 SoC found in the Orange Pi RV2 are not specified, but they're widely believed to be x60 cores like those in the SpaceMIT K1 and M1. And finally, our oldest board here, the VisionFive 2, has 4 1.5 GHz U74 CPU cores. So, here we have our 5 RISC-V SBCs, the Orange Pi RV2, the Banana Pi BPI-F3, the VisionFive 2, the Sipeed Lichee Pi 3A, and the Milk-V Jupiter, which is a mini ITX board that I've got in this case. I first looked at the Orange Pi RV2 in May 2025, running a custom image of Ubuntu that Orange Pi call 100 Noble. The image for this was released in April 2025 and is what will again be running on the Orange Pi in this video. However, all the other boards here have had a significant number of operating system updates since I first tested them. Starting with the Milk-V Jupiter, this is now running Biambu 2.1.1. This is based on Ubuntu 24.04 rather than Ubuntu 23.10, which was the basis for the version of Biambu I previously tested on the board. And the 2.1.1 image was released by Milk-V in March 2025. Also running Biambu is the Banana Pi BPI-F3, although here it's the very latest version, 2.2, from May 2025. And this is a generic image downloaded from SpaceMIT, which I accessed via the Banana Pi BPI-F3 wiki. Next, let's turn to the VisionFive 2, where we'll be running a Debian image released by StarFive in September 2024. And finally, on the Sipeed Lichee Pi 3A, we're going to be running Biambu 10.15. This image was released in July 2024 and is based on Ubuntu 23.10, which is no longer supported. In theory, the Lichee 3A can run Biambu 2.2 just like the Banana Pi BPI-F3. However, when I imaged this to the board's eMMC, it would not boot. I therefore returned to version 10.15, which is what I tested on the Lichee Pi last summer. And this did then prompt to update to Biambu 2.1.1, so I ran the automatic updater and this did work fine. But once the update completed, the board again would not boot. Now, there have been over 15 versions of Biambu released since July 2024, and one of these may work with the Lichee Pi 3A. But after 6 hours of experimenting and testing and installing, I gave up. And so sadly, the Linux distro we're testing on the Lichee Pi 3A is not as up to date as the operating system software on the other boards. Right, here we are running Biambu OS on the Milk 5 Jupiter, where we're going to run the Geekbench 6 CPU benchmark. Unlike SysBench, Geekbench is available for RISC-V. It's available in a preview version, as we can see down here, although being a preview version does constrain what we can do, as I can't apply my professional license, so we'll only be able to see the final results by going online at the end of each test. Just to show you the difference, if we nip on over to my i5 10400 test rig and run Geekbench 6 Pro in Linux Mint and then speed on through, we can see all the results as we go, with the overall single and multi-core scores displayed at the end. But if we return to the Milk 5 Jupiter and run the RISC-V preview, whilst we do get our system information confirmed, during the test no results are displayed. But if we speed on through and go online, there we are, we have our single and multi-core scores for the Milk 5 Jupiter. So let's go on over to the Orange Pi RV2 and again run the test. There we go, and once again we'll speed on through. And there we are, we've got our Orange Pi RV2 scores. Next, it's the turn of the Banana Pi BPI-F3. And once again, we'll use the magic of filmmaking to speed on through and obtain another set of results. Moving on, let's run Geekbench on the Sipeed Lichee Pi 3A. And here, as on the other boards, things start out just fine. But if we drop out of fast forward during the multi-core test, dearie me, whilst running the photo library test, the board resets itself so we don't get a result. And I've tried this several times and it always crashes during the photo library multi-core test. So let's move on to the VisionFive 2 and execute things there. And for a final time, we'll speed on through and get our last Geekbench results. So let's put everything on a table, and as you can see, I've added in the run times to complete the single core tests and overall, which means that we at least have something to work with for the Lichee Pi 3A. And for comparison, we'll also add in results for a Raspberry Pi 5 and my i5 10400 PC. These clearly show that RISC-V, whilst advancing rapidly, has some way to go before it becomes a viable competitor to ARM and x86 for most desktop and server applications. However, for me, the most interesting result in this test is the performance, or lack thereof, of a Lichee Pi 3A, which in theory has roughly the same or identical CPU cores as the other boards aside from the VisionFive 2. But the CPU information reported for the Lichee Pi 3A by Geekbench was very different to that for the other boards here that contain, in theory, identical x60 CPU cores. Next, initially back here on the Milk 5 Jupiter, we're going to run another CPU test called SilverBench. This runs in the browser and is a multi-core comparative speed test that uses JavaScript to ray trace a test image. And do note that the test is entirely CPU based, and indeed I've struggled to find a GPU test that I can run across all the RISC-V hardware in this group review. So let's start the test. There we go, and as this will take some time to execute, we will speed on through. And as we do so, it's important to be aware that SilverBench performance is very different in different browsers, with, for example, the test running about 10 times slower in Firefox, and so here all the tests are being run in Chromium. And oh look, by the magic of filmmaking, we've come to the end of the test. We've speeded forward in time at just the right rate, and by now we know the score. We're now going to repeat the test at speed for the Orange Pi RV2, for the Banana Pi BPI-F3, although sadly this crashes mid-test and I've tried it several times, and sadly it always crashes. So we'll move on to the Lichee Pi 3A, and then finally the VisionFive 2. And if we again tabulate the results, the data is very interesting indeed. Not least, the VisionFive 2 has now come first, with higher results being better in the SilverBench performance test. And the final rankings are so different to those from the Geekbench results that I think we'll now run a third CPU benchmark. So, back on the Milk 5 Jupiter, I've installed GIMP, here under Graphics, there it is, and it's GIMP 210 as that's what's currently available for RISC-V. And now the package has loaded, we're going to create a new image. It's going to be the default of 1920 by 1080, there we are, and I'm going to go to Filters and Render and Lava, which on its default settings is one of my standard performance tests. So let's press OK and speed on through. And there we are, the Milk 5 Jupiter has done the test in 27 seconds. So let's now repeat with the Orange Pi RV2, which manages the same task in 34 seconds. So let's now try the Banana Pi BPI-F3, which kicks off fine, but sadly crashes out of GIMP before it completes. And again, as in the last test, it does this every time, so there's nothing I can do. So let's go on over to the Lichee Pi 3A, where sadly I cannot even install GIMP, perhaps due to the software issues discussed earlier. So all this means we're back to the VisionFive 2, which works perfectly with a lava filter runtime of exactly 1 minute. So, putting the GIMP filter result tests on a table, we are a little short of data. But if we combine all 3 performance tests into one graphic, the results are, I think, quite revealing. Not least they remind us that no individual artificial benchmark can ever be relied on. And I'm not that surprised to see that the GIMP filter test run in a real application is the only performance measure that reflects how we would expect the boards that could complete it to perform, with the Milk 5 Jupiter having the highest hardware specification. Overall, the Jupiter has also completed all tests with a decent performance in each of them. Similarly, the Orange Pi RV2 has put in a good showing, as has, for that matter, the VisionFive 2. We then get to the Banana Pi BPI-F3, which, until I did this group test, was one of my favourite RISC-V SBCs, but which, like the Lichee Pi 3A, has only completed 1 test. And for both of these boards, the issue may of course be software rather than hardware, but I have to test complete systems, and I do hope that the results here are of some assistance in comparing RISC-V SBCs. Right, let's move on to storage. And as we can see, all of our boards have got a microSD card slot, at least one M.2 slot for an NVMe SSD, and either some onboard eMMC flash storage or a socket to take an eMMC module. In my previous review videos for each individual board, I've used HD parameters to test storage read speeds. And for this video, I've also repeated the tests just to check if things have changed. And so here, with a few updates and additions, given the updated software now running on most of the boards, is the storage performance I've now measured. As we can see, the top 4 boards listed are all delivering a pretty decent NVMe SSD speed of about 600 megabytes a second over their 2-lane PCIe 2.0 interfaces, and microSD card speed is also decent, aside perhaps on the Milk 5 Jupiter. But on a mini ITX board, this really is not a concern. What is more of a concern are the storage speeds on the VisionFive 2, especially the microSD card speed, which, as we've just seen, I have retested and remains at a meagre 21 megabytes a second. Right, I know some of you are interested in power use, and so back here on the Milk 5 Jupiter I've got a power meter connected which is showing an idle power use of about 7.4 watts. So let's stress it out. Let's bring up the SilverBench test we ran earlier. This is pretty good at stressing out all the cores. Let's click on benchmark and it should start to stress things out and increase power use. It has, and I think we'll record a load power use here of 10.1 watts. Next, we'll turn our attention to the Orange Pi RV2, which is displaying an idle power draw of 3.3 watts. So let's bring up the SilverBench program and again run the benchmark and let it run through a little bit. Start drawing lots of power. How far is this board going to go up? 5.5, 5.6. It seems to be all 5.8, 5.9, 6.2. It's still going, although it's now dropping, but I think we'll take that as a maximum power use at load of 6.2 watts. Next, we'll turn our attention to the Sipeed Lichee Pi 3A, which is showing an idle power use of 3.1 watts. But again, we will go to the SilverBench program in the browser and start it off. Give it a second to settle down. Power use is going up. What are we going to hit? Oh, 6 watts, 6.1 watts, 6.4 watts. Yes, I think we'll record, about 6.4 watts. Next, it's the turn of the Banana Pi BPI-F3, which is showing an idle power draw of 4.3 watts. So let's once again go across to the SilverBench test and start it off. And we have to be aware that this computer will crash during this test, so we need to get our reading in pretty early, but I think we'll do that. There we are, we're reading a power use at load of 7.1 watts. Finally, it's the turn of the VisionFive 2, which is idling along at about 4.7 watts. So let's bring up the SilverBench program and max out its cores. Here we go. And how will power use go up? And we see power use at load of about 6.8 watts. So let's put all of these results onto a summary table, and there we are. We've got a complete picture of the power use at idle and load for our 5 RISC-V SBCs. Finally, I can't complete a group test of hardware that runs a desktop operating system without at least briefly looking at streaming media playback. So here on the Milk 5 Jupiter, let's nip across to the Christopher Barnett YouTube channel and bring up my test video full screen, where once things have settled, and it does take a little bit of time to get to this point, but when we get to this point where things have settled, 1080p playback is pretty good. We also get a pretty much identical result on the Orange Pi RV2, where again 1080p playback is fine once things have settled. And it's the same story on the Banana Pi BPI-F3, as well as on my Lichee Pi 3A. The only outlier here is the VisionFive 2, which does drop a lot of frames when streaming 1080p, although performance, at least in Firefox, is better streaming 720p. And indeed, when I made my RISC-V week video back in 2023, I spent 7 days doing all of my streaming media playback in 720p on the VisionFive 2. So, overall, what have we learned? Well, if you want to delve into RISC-V, the Orange Pi RV2 and the Milk 5 Jupiter probably offer the best value. This said, I still very much like the VisionFive 2 and the Banana Pi BPI-F3, both of which continue to enjoy good software support. And indeed, more generally, it's great to see that RISC-V single board computers, RISC-V development boards, continue to have good support from their manufacturers long after release. which is something we don't always see in the ARM SBC marketplace. And software support is going to continue to get better and better. Not least Debian 13 is due to release fairly soon with RISC-V support, and I've just seen that Red Hat Enterprise Linux is also going to be ported to RISC-V. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.